Hello, my people. I remain your one and only maths and physics coach. Today, we'll be looking at 2015 UTME question physics, number 1 to 10. Now, what we have in number 1, let's go straight to the business. Number 1, what do we have there? That's the next thing to discuss here. From the question, it says that a piece of rubber 10 centimeter long stretches 6 millimeter when a load of 100 Newton is hung from it. What is the strain? Number 1 says that original length of that material is 10 centimeter. We can convert this, it depends, but let's leave it. Why the extension is 6 millimeter. Then, when a load of 100 Newton is hung from it, that is, the force applied here is 100 Newton. The question is to find strain, unknown. Now, just like I said, if we want to discuss this, our strain is known to be what? Strain, if you remember, this is elasticity topic, equals extension over original length. And from what we have there, extension is 6 millimeter. Original length is 10 centimeter. So you must make the two of them the same so that you can what? Divide. This is basically, if you convert 6 millimeter to centimeter, you'll be talking about 0.6 centimeter over 10 centimeter. In essence, our answer here will be 0.06 because it does not have units. Centimeter will cancel centimeter. And in essence, our answer will be 6.0 times 10 raised to power 2. Let's check the answer part. From the answer, none of the answer is correct because if you look at A and B and D, they are the same thing. So perhaps you made a mistake while trying to write the solution. Now straight to number 2. Straight to number 2. Number 2. In number 2, let's see, it gives us a diagram. That what is this diagram? We need to tell them. It said the diagram above shows the lens arrangement. In which one do we have this kind of arrangement? That's what they are saying there. So for us to get this, we need to know the types of the lens arrangement we have. Now, once they give us that the objective lens has a long focal length, that's FO, you see there, that focal length of the objective lens, while the eye lens has a short one, and they arrange them such that the focal length coincide with the focal length of the eye lens. Both of them coincide at the same time. That one is astronomical. Compound, they will arrange it, they can interwoven. Binocular, we have 3 lenses like that. While periscope, we use only plane mirror for it. So the answer here for number 2 is astronomical telescope. Is that okay? So what they gave us here is astronomical telescope. Is astronomical telescope. So I think that is C. Now let's go to number 3. Number 3. Number 3, from what they said there, they said what is total resistance in the diagram? And then we can see that there's nothing like resistance here. They gave us magnetic flux and they want to calculate resistance. So the question is wrong in that case. It's very, very wrong in that case. Now let's go to the next level. What's the next level? Question number 4. Number 4 says that a body of mass 6 kg rests on an inclined plane. The normal reaction R is given to us there. The frictional force, limiting frictional force, is F is there. If F is 30 Newton and G is 10 meters per second squared, what is the angle of inclination? So that's one. This one, no solution here. In number 3, we have no solution. No solution as we have wrong diagram. Wrong diagram. Perhaps if I see the right diagram, I will give you the solution to the question. Now, those who printed it or try to get the question, they didn't get the right question. Now, that number 4 that I was saying, they gave us M mass as what? As 6 kg. They gave us the frictional force. I like putting R there to show that it's frictional force as 30 newtons. They gave us G as 10 meters per second squared. We have to calculate theta. Theta unknown. But from what we have here, we know our theta from our formula. We know that frictional force guy is equal to mg sine theta. In this case, sine theta is equal to fr over what? Over mg. That is, sine theta is equal to fr, which is 30, all over 6 times 10. 0 cancels 0. 3 here 1, 3 here 2. So we have sine theta equals half. That is, theta equals arc sine half, which is equal to 30 degrees. That's the final answer. Let's see the answers there to know the one. So that is D for our answer. D for our answer. So in essence, we have D as the answer. So here is D. 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 Now let's go to the next question. Number 5. Number 5 says that the speed of light in air is 3.0 times 10 raised to the power 3 meters per second. Its speed in glass is having a refractive index of 1.65, having refractive index of 1.65, then its speed is what? What's speed that time? That's what they are saying here. So now to get at, so there's a problem with the question here. This place should be 8. This one should be 8. It can be 3. So the speed of light is 3.0358. Is that okay? So let's solve it so that you can be happy. Now from the question they gave us here, number 5 says that the velocity in air is 3.0 times 10 raised to power 8 meter per second, while the refractive index say is 1.65. We have to calculate the velocity in glass. Now, refractive index in this context is defined as the velocity is coming, the rays coming from air to where? To glass. That's the way this one will be solved. So in essence, in terms of velocity, it means the velocity in the first medium over velocity in the second medium. So we now have 1.65 equals VA over VG. Don't forget, VG is velocity in class. So we have 1 VG is equal to VA, which is 3.0 times 10 raised to power 8 divided by 1.65 in meter per second as usual. Now let me pick my calculator so that we can be happy for this. Let's pick the calculator so that we can be happy. So we have 3 divided by 1.65. See what that gives us? That gives us 1.818181 like that. So it's like we are having 1.82 times 10 to the power 8. Let's go back to our solution. This 3 over 1.65 will give you, so we don't need to calculate everything since it's just standard form. So 3 over 1.65 will give you 1.82 times 10 raised to power 8 meter per second. I told you that that thing is 10 raised to power 8, not 10 raised to power 3 they wrote in the question. There are a lot of typographical error in the question. Now the answer here is A. What on number 6? So that's A. Let's write the answer there. A. Then number 6. What's number 6 here? Number 6 says that longitudinal waves do not exhibit a refraction, polarization, diffraction, reflection. The right answer here is polarization. So all longitudinal waves, they don't exhibit that. So I will write it here that longitudinal waves do not exhibit polarization. If you need more explanation or anyone I give you, please indicate whether you are in the group, and if you too want to learn more about this UTME physics, you can join our group down there in the description of this video. Then if you like what we are doing, subscribe hit the subscribe button and join the group so that you won't miss any video when I upload it. Now number seven. Number seven says that a device that converts sound energy into electrical energy is, it said, A, the horn of the motor car, the telephone, earpiece, loudspeaker, and microphone. The answer here is microphone. Now, this question is always confusing the students. So, I will explain the difference between microphone and loudspeaker now. The difference is very, very obvious. I said the answer is microphone converts sound to electrical. And the answer there is D. Now you see, loudspeaker converts from electrical to sound. So when you put the mic there, the wire of the mic there, you talk to the mic, and that mic will bring out sound. Loudspeaker. The mic is only converting your sound to electrical in the wire. So electrical signal is what you have there. So from the electrical signal, the loudspeaker will now convert it to sound. So loudspeaker converts from electrical to sound. But most of the time I see students saying wrong thing. Now what is number 8? A good calorimeter should be of A, low specific heat capacity and low heat conductivity. We have high speed specific capacity and low heat conductivity. C is high specific capacity and low heat conductivity, while D is low specific heat capacity and high heat conductivity. Okay, now how you get this answer, I will lead you to the answer, don't worry. I will lead you to the answer. Number 8 in this case. A good calorimeter, what we want it to do, what we want calorimeter to do is to reduce the heat loss. To reduce the heat loss. According to the question, the question says that what are the qualities or character or properties of a good calorimeter. So I was about explaining that. Let me just explain. From our formula, one good thing about a calorimeter is that it should have a good conductivity, because if it has a low conductivity, it must not conduct it very well as the content inside it. It must conduct easily. But in terms of specific capacity, I will explain that one now. From our formula, we know that specific heat capacity, SCHC, is directly proportional to what? Q. Inversely proportional to what? Change in temperature. Is that okay? Change in temperature, which means that as specific heat capacity, increases, what happens? Conductivity decreases. Which means that if you want high conductivity, heat conductivity, you must have low specific heat capacity. So the answer here is low specific heat capacity and then what? High heat conductivity. That is the way we solve this. So with that, you'll be able to understand this perfectly. Let's now go to the question. A good calorimeter should be of low specific capacity and high heat conductivity. That is D in this place. So let's write that one so that we can write on. D is the answer. Now we go to number 9. Number 9 of the question. Number 9 says that which of the following is most strongly deflected by a magnetic field? Particle, a beta particle, X-ray or X particles, gamma rays, then X-rays. See, all this one, they are not deflected at all. Only beta particle is deflected. If you remember in radioactivity, where when the ray from uranium is passed into the gigamolar tube, so one of the particle is deflected slightly, that is alpha particle. One is deflected strongly, that's beta particle. And the last one is not deflected, gamma ray. So gamma ray has the same property with X-ray. So that is why, except in only one thing, that gamma ray is different from X-ray, and that is what? That gamma ray is produced in the nucleus, but X-ray is not. So but another thing, they go together. So beta particle is the final answer here. So our answer here is that what is the ray that is or the particle that is strongly deflected in magnetic field is what? Is beta particle. Beta particle is strongly deflected in a magnetic field. So we go to number 10, which is the last question for the day. Next time I'll be uploading more on the remaining 10 and the remaining questions. I will pick 11 to 20 of 2015. Now let's go to number 10. Number 10 says that if a beaker is filled with water, it is observed that the surface of the water is not horizontal at the glass water interface. This behavior is due to surface tension. Nothing else. Let's see other options they give us. They give us friction, no. Surface tension, no. Yes. Then they might give us viscosity. Let me see. Viscosity, evaporation. I know they will put that there. But the answer here is surface tension. Surface tension. Make the surface of water behave as if it is what? It is covered with something there. So we don't see it directly like that. So the surface will not be as normal as we see it. So the answer there is surface tension. So another time they can ask the question that the surface of water or liquid behave as if it is covered with an elastic material. So it goes together. It's still surface tension. So that is the end of this solution today. I remain your number 1 and only maths and physics coach. Untitled is the name. And don't forget to click the subscription button in the YouTube so that you can get first-hand video immediately I upload it. See you when I see you. And you, if you want to join our Telegram for JAM, Maths and Physics, you are free to join us. The link is down there in the description below. See you when I see you, and bye for now.